Testing sound. It's always good to test. As my previous bug issues have shown. So, last time I had a bug. And I didn't want to go through the full debugging on process on stream because there'd be a whole lot of trial and error. And I didn't necessarily want to subject everybody to that. But now I get to lead you through the fraught process where I found it. No, I'm not I'm going to be writing the programming. I'm writing the programming language in C++. The programming language is one of my own invention. It is just kind of a toy, but a semi-serious toy. Like today I'm implementing doing part of the implementation. Why would I've never even heard of Idris 2. I know C++. I don't know Idris 2. I know Python. I know C. I know Fortran. I know assembly language for several different processors. I know Perl. Dependent product types. What are dependent product types? Again, dependent function types. I'm not quite sure what you mean by that. So in other words, you pass in an array as one argument, and then the second argument is an index into that array. Right. Um, you just pass them in. Like there's nothing to indicate that function arguments are dependent upon each other in C++. Um, you can still pass them in and use them, but okay. I have code that does that exact thing with uh, similar syntax in this thing. Not similar syntax. So somewhere in here, I have something where I'm creating a vector here, right here. Here, I'm going to switch to the where you can see it. So this line right here is creating a vector, a list. Yes, okay. I'm not an Idris 2 person, and I'm not a functional programming person. I'm not really interested in doing either of those two things. Yes. Okay, that is true. So that would actually be more like what C++ calls a standard array. Um, there's an array type in C++ where the length, in fact, is part of the type of the array. Uh, we'll just make a little scratch pad here. Uh, no targets. No, we're not going to version control it if it asks. It probably will. Cancel. Okay. You can, but it's a pain. Here is how you would do it. Um, like that. It's now you're passing in the so you would then go right, and then it would work, right? This would be A would be an array of 3 integers, right? And that would work. Um, now I don't think there might be one other way you can do it, but I don't think it would work. Um, no, I don't think it would work. Uh, I think you would have to make it a compile time argument to the function. So here is another idea I have for how you might be able to do something. Um, yeah, no, you can't do it. You can't do it. You have to if the return type. Yeah, this would not count as being const expr. It couldn't be done. Um, you'd have to make it a compile time argument effectively, which is basically a template parameter. Um, yep, you'd have to do it this way. And if you don't specify, if you do auto, then it deduces it from the return statement. Um, this only works in a limited number of cases, but it works. Anyway, um, we are now going to disappear this because I don't really care about this file. I don't use this IDE. Anyway, I had a bug last time on my stream, and I had been spending some time figuring it out. It was a crash bug. It was causing the program with exit with SIG-SIG-V. The one step I took was turning on the address sanitizer for the debug build, and also the undefined behavior sanitizer, and also the use sanitize address use after scope sanitizer, um, just to try and catch all the possible problems that I think it might have been. And it actually did catch something. I also added some probes here when the stack frames are created and destroyed, because the bug was centered around the stack frames. And I learned this by the sanitizer gave out this, like, if you want to look at really what the sanitizer um, yeah, that's what the sanitizer actually prints out. And some of this was useful. Like, this kind of gave me an idea of what might be wrong. Like, all these are guard bytes that the sanitizer puts in memory to check whether something's being fiddled with or not. And then it also outputs these uh, stack traces of where the memory that was allocated that seems to be part of the problem, which is right here, and then where in the function call stack the problem occurred. And I discovered that the problem was happening right there, right? Why was the problem happening right there? And I played around with this and didn't learn too much about it. It had something to do with stack frames, I was sure. And so that's the reason why I added this stuff to do this printing out. But in thinking about stack frames, this is actually a bug I figured out the answer to. At least I think I did, because I haven't tested whether I figured it out or not. I figured out the answer to just by thinking about my program. And one thing I have avoided doing in my program in most places is using bare pointers, because bare pointers are dangerous. And this place right here is the place where I was the most worried about using a bare pointer, because there's this stack frame and it is a long-lived thing. The pointer lives for a very long time. And it's pointing at something that, potentially could disappear while the pointer was pointing at it. It won't, because what context in which the stack frames are created is during the evaluation of an AST that won't change while the stack frame exists. The other place it exists is up here in here at identifier. It identifies the statement list that's the scope for an identifier. But this identifier will be created in the context of the statement list that contains it. So yeah, it's not going to, again, be a thing that will exist beyond the scope of this pointer. In fact, actually, I was a lot more worried about this pointer than I was about the other pointer. But there was another place where I used it where it was a mistake. And it was a very short-lived place, so that's the reason why I didn't worry about it as much. It's a pointer to the stack frame. The problem is if between find identifier and the time you then try to use the identifier that you found, well, it's pointing into the stack frame. The stack frames are organized, like are being kept track of, not on the real stack. There's a separate stack here that's being kept track of as part of the execution context in the simple evaluator. And so the execution context stack consists of basically a bunch of slots, indexed slots, and identifiers know which index they're going to be in the slot. And so they can refer to the proper slot spot, right? And so I know how many identifiers at the time of execution. I know how many identifiers have been declared within a particular scope, and so I know how to be big to make the set of slots for that scope. So that's what I do. And that's what the stack frame contains, right? It contains this bunch of slots. And I could have, well, I can't do it constant because I don't know at compile time because, yes. So I have a bunch of slots here in the stack frame. These, what is the slots? The values. And a pointer to the statement list of the content of the, basically the AST version of the scope that the identifiers were declared in. And so when I do find identifier, I go back through the stack looking for the identifier that matches this. The identifier knows which AST scope it came from. So I can look at the AST scope and look at, and the identifier also knows its index. And so I go back to the stack frame looking for the matching AST scope so that it knows which slot in that value structure to find it. Well, if between the lookup right here and the time you use the value in the lookup, well, visit here might add new scopes to your stack. That's nice. Yes, that is nice. So in between the time you make this lookup and the time you do it, like the stack might change. And the stack isn't ever going to get smaller. You aren't going to pop out of your the execution frame that you're currently in, the activation record. These actually might be more appropriately called activation records rather than stack frames, but same thing. You're not going to be popping out of the activation record that you're currently in. And so, this is going to, in some sense, refer to a valid activation record. The problem is it's referring to a stack frame pointer. This is the stack is a vector of stack frame keys, right? It's not a vector of stack frame pointers. It's a vector of actual stack frames. And so the pointer is going to be referring to somewhere inside the memory for this vector. Well, if this vector expands while inside this visit here to go down the AST to evaluate subexpressions, which may of course contain their own statement lists, then something might get pushed onto the stack. And anytime something is pushed onto the stack, well, the entire vector memory might get moved someplace. And so the stack frame pointer becomes invalid because it's pointing into the memory that's part of this vector. And yes, C++ vectors are not technically vectors in the sense that you might normally think of them. I don't know why they persisted in calling them vectors. I think the C++ standards committee, when they were standardizing the whole STL, became very enamored of mathematical language and decided to call them vectors, even though they weren't. You are right, they are lists. But the other thing is people in C land associate list with linked list, and of course, vectors are not linked lists. They are sequential lists, which in fact in C and C++, the fact that they're sequentially laid out in memory is very important for certain algorithms that operate on them. There's actually a whole class of algorithms that have special case code for handling iterators that are iterating over contiguous memory. But so this pair here is returning the stack frame pointer that may, of course, become invalid at some point in time. And, it's supposed to be used pretty quickly, right? Because find identifier, you're going to use it right away. But in this case, I'm going to find the identifier, and then I'm going to use it after I go through the subexpression. And that's not it's not the right way to do things. Now, this is in part of evaluating a variable declaration. So this subexpression shouldn't be a whole, if it contains a function call, it might contain a whole other scope. But if it doesn't contain a function call, which none of them do right now, I don't have any tests that test my new function call thing. If the doesn't contain a function call, there should be no extra added stack frame. So I'm not quite sure why there was in fact a problem. But this is clearly a problem. I should not be returning this from find identifier. So what I'm going to do here is I'm going to instead be doing the, let's see here. Yep, there we go, like that. And then here, I'm going to have, and then, so we're not going to do value dot first is going to be actually what we're going to do is stack. There, like that. And then down here, I'm going to search up the definition for find identifier. Here, I'll just search it up here. Oh, here's another place. No, that's the first place I use it. So then here's another place where oh, no, it's the same place. Oh, nope, this is another place that I use it. Okay. And so here I have to do okay, and then next. Now we have to change it so that this is the right type. Silly thing. Change it so that this is the right type. Then leader god. Hello there, leader god. I haven't seen you before. What's your interest in this? Hello. Not see here. So what we're going to do here, in fact, actually, the fact that I had to resort to doing this should have been a sign to me that I was doing the wrong thing. Oh my. Um, I think that's the right thing to do. Oh, I don't know. Is this the right thing to do? I hope it's the right thing to do. And of course, oh, indeed. Ah, it is fine to hold this reference for this period of time because I'm not doing anything that will change what the reference is change the where the reference is referencing. Change, yes, move the thing that is being referenced around. Oh, there. That should work. Now let's try running all the tests and see what happens. Darn. And the sanitizer is still complaining bitterly about things. I did not fix the problem. And this thing didn't recognize the sanitizer output as being sanitizer output. Yes. This is all the sanitizer output, which is going to be really obnoxious to parse. But I can make some guesses as to where there we go. This is the one that I probably want to look at. Line 140. So now the error is on this. Okay. We're going to actually debug this now. Okay. And then step over. So L value. What is the value of L value? So first of all, what does our stack look like? We have a bunch of values, have two values on here. And they're both, one's 2 and one's 0. Which they shouldn't be, actually. At this point in the code, that's not what should be here. That was another vexing thing, is I don't know why that was happening. VD, this is the actual variable that's being declared. It's going to be at var index. Oh, this is the variable declaration. But they should still both contain 0. Why was one contain 2? Should both contain 0. So this is 3. I should be shoving the value of 3 in here. The identifier is this, var declarations, var info, X. I should be saying X here. We go back up through the call stack for this. This is a test for the while loop. And I'm evaluating this, var x equals 3. So that's this very first thing here where I'm doing var x equals 3. That's what we're looking at right now. Okay. As I said, this should not have 2 in it. It should have 0 in it. I don't know why it's being initialized and having 2 in it. Now, L value should be a thing, but it looks like it's been optimized out, which is very irritating. Now we're going to step over this. So now if we look at this, we should have a current result of 3. Because the expression that should have been getting evaluated is numeric literal, and every expression has a result, and the result inside the simple evaluator here, our results of expression go into the current value, which currently is stuck at being an unsigned current result. It's stuck at being an unsigned UInt or a UInt max. This I might have to fiddle with. I don't know. One of the changes that I made in order to implement functions was I now have this more this more complex type for the variable value, saying that the variable value might be one of several types. And I give UInt max and I give func declaration pointer as being the one of the 2 types that it is. That's the change that I made. And so, yes. Find identifier. Okay. Now, do I know what the value of L valued at first is now? No, I don't. It's optimized out. Let's see what happens when I get a segment fault. Oh, this is so irritating. I wish it didn't optimize out what the value of L value dot first was. I think I might have to just print out what the value of L value dot first is. Uh, like that. Because they are both indexes, so they'll both be integers. So I'm going to debug it again. And then we're going to step over this, over that. Has L value still been optimized out? It has been, but we now have this thing, which we should now see. Well, it's no wonder that resulted in a segment fault. Okay, I think we need to step into find identifier and find out what the heck here is happening. Because I think I did this wrong. So, and then step into okay. Now, this is really annoying because it's not telling us anything about what our begin and our end are. Hmm. I think what I'm going to have to do is redo this function to use indexes instead, because I care about the index, and getting the index out of our end or our begin is a huge pain. Um, okay, so the AI did a whole big bunch of stuff for us here. I don't think I trust any of the stuff that it did. I want to do it myself. And that's not what I want to check either. If so, I do have something called stack. I'm inside simple evaluator. Simple evaluator very definitely has a variable called stack. Why does it not think it does? What is the problem here? Anyway, if stack frame is, no, if stack frame dot ctx okay. So stack should have stack frame keys. Stack frame keys should have a context. Oh, that's one of the problems. Yeah, there. I don't understand the problem with returning frame here. Oh, I know why. Okay. There. Because we're returning a pair. And we're going to return this is wrong, but that's what we're going to return. All right. I skipped out on using the algorithm because trying to use our end and our begin so that we search from the end is, and then doing arithmetic on those iterators was a very confusing situation, and I didn't want to have to deal with it. So this is what I did instead. Um, now let's see what happens. Okay. So it still didn't work. Um, and we still have a sanitizer problem, but it didn't fail nearly as hard as it did last time. Where was the sanitizer problem this time? That, that, that. So it was still in the same place inside of variable declaration. What is it about variable declaration that's causing this to happen? So the big change that I made that surfaced this bug, I suspect this bug, first of all, this whole thing with this find identifier was definitely a bug that should be fixed. I should not have been returning a stack frame pointer because as things get more complicated, there will be things that happen between find identifier and using the results of find identifier that may involve creating or destroying stack frames. And any alteration to the vector will render any pointers into the vector's contents useless. And so I should not be returning a pointer into the vector's contents. I should be returning an index to allow you to index into the vector. Um, and that's what I was doing. That's what I changed. And that definitely is a bug that I wasn't doing that. But something still is going wrong. The change that I made that surfaced this bug was this part right here. Now, when I create a new stack frame, context, I'm passing in values. Now let's see. I only create stack frames. There's a thing called a scope here. There's a scope frame because I wanted to make sure. Scope frame is basically a little utility class that wraps RAII around stack frames. And so when the scope frame comes into scope, it adds a new stack frame. And when it pops out of scope, it pops off the stack frame. Now block stack dot push back block. Okay. So there's a block stack. Oh, for this is for compile time. Okay. Where do I put on a stack frame? Where does that appear in parser.cpp? I'm using this somewhere. Like I declared it, right? I'm using it places. Find usages. Okay. Yes. Okay, yes. There's other uses of this. Come on. That's a definition. Okay. I know where it should be used, so let's go look there. It should be used not parse new scope. It should be used in simple evaluator when doing the statement list. There we go. This is it right here. Oh, I guess I don't use it directly. So stack.inplaceback. So basically create a new stack frame. And we only do this if the variable declarations are not empty. We don't bother to create a stack frame for a new statement list that has no variable declarations in it. And then SL, that's basically the address of the statement list. And then, which is a bear pointer, have to like do all kinds of weird things. And I don't want to shift it to using something more sophisticated like a shared pointer. And this should work. Standard vector, var val t. So yes, that is the type for the second argument is a standard vector of var vals. And then var declaration, that is the correct size, and then var, the thing to fill it with. Maybe this decision shouldn't be made here. And I should do it someplace else instead. So we're going to make this explicit. And then context and var vals is going to be like this. The problem here is I don't think there's I'm going to leave the default constructor for var vals. So we're just not going to do it like this. And then what we're going to do, I don't want to do it that way. I'm going to say var values dot reserve, and then yes. This is a thing to do. Then here we'll just do there. That should have done that to be doing the same thing. That's in case that vector constructor, the vector constructors are kind of confusing. It's not obvious exactly what is going on here with the vector constructors. Like if you have from range, you could have other. So there's a bunch of that take the size as the first thing. And then they want the value, size, value. But yes. That should have been the right thing, but I just to make sure, I'm going to do it this way instead. Partly it wasn't initializing the values properly. Like I looked at the vector had a why was 2 sitting in there? Copying? Was it copying or was it moving? Anyway, I compiled. What happens if I run it? Huh. okay. And the sanitizers have nothing to say. So I fixed my problem. The problem is I don't know why the problem was fixed by doing this. This has something to do, I don't know. So I was pretty sure I was using this constructor for vector, but it was probably also moving the vector, right? Like I was doing here in statement list, when I was doing the in place back here, I was calling well, I created a constructor here for stack frame, but it was taking a vector as an argument. I was passing a vector here. So the vector was being moved after create, and then it should have been being moved back into the, in fact, I did move it. I standard moved it into this. So there are two moves, moving the vector into here. I have no idea. What happens if I do it this way instead? And then comma var val t. What happens if I do that? And then just do this, right? That should still work. Do you have any idea why this, why what I did fix the bug? Again, no sanitizers complained, program worked, bug fixed. So it was something about moving. It wasn't this constructor that was the problem, because I used this constructor here to directly initialize this var values. I need to test a stack that's deeply nested. I need to have a recursive call that's not insignificant, because if it's the move constructor for stack frame T, that might be a problem. It's the move constructor for, well, if it's the move constructor for vector, that's very definitely a weird problem. I don't know why the move constructor for vector would have caused that to happen being called twice. I don't know. But that's what was happening here. Before, I was passing in SL. And honestly, the stack frame did have enough information from the context to know, from the statement list, to know how many variable declarations it needed. But there's another problem here. Simple evaluator var decal. Oh, so this is going to be interesting to implement, because function declaration here is going to have to create the stack frame before it calls the function. Oh, no, it's not going to be that big, that different. The problem is the function contains a statement list, and the statement list, oh, this is going to be a problem, because the function declaration will contain a statement list. This is tricky. Anyway, do you have any questions about any of this code? You haven't been on this stream before, so you haven't followed the development of this whole thingy. I can give you That's where it is if you want to look at all the code. Um, Otherwise, I fixed my bug, and so technically I'm done for this evening. Um, that's what I wanted to accomplish this evening. It really vexes me that I do not understand why this fixed the bug. Clearly, there was something involved with the way the vector move constructor was working um, that caused this whole thing to not work the way, like the statement list thingy here, to not work the way it should work. Wasn't the most efficient thing to be doing in the world. Moving vectors is pretty cheap, but still, you should avoid moving vectors if you can. Yeah, I don't know. I don't know. You know, one thing I can do with the stack is I can look. No, no, that won't be the right, because if it's a recursive function call. Anyway, this is a parser. It's a recursive descent parser. There's two different kinds of stacks that get created in the process of all of this running. This concerns the runtime stack that is created by a visitor called the simple evaluator. It's a AST visitor that is used for, in fact, running the program. This is what runs the program that the parser is parsed out. Um, I am about to add function declarations. In fact, I added all the parse stuff for function declarations not too long ago. There's a parse function declaration somewhere. Yep, here. And this is parsing function declarations, and it was a reasonably complicated function to write. It actually probably should be simplified. A lot of this parser has some kind of repetitive code patterns that should be simplified. I should be writing some kind of functions to uh, make these repetitive patterns go away. But, right. And as part of that, function declarations are treated as variable declarations, right? Um, so uh, somewhere in here, yes, here we go. Declare var func name, right? So the function name is a variable. It's just an identifier. It's a variable and it holds a value. The way the rest of the parser, the way the rest of the language works, that variable's value will not be allowed to change. But uh, as far as the execution engine is concerned, it's just a variable with a value. And in order to support that, I had to change this whole thing so that I could store variants as variable values instead of just uint max, because all variables in this language were previously unsigned integers, unsigned 64-bit integers, and that was that. Um, but uh, this the supporting function declarations required that there be variables that also have function declaration as a type. Um, and I'm probably going to add strings and some other things. I'm thinking of adding compound types before I decide I'm done with this toy language. Um, so structs, I'm thinking of adding structs. Uh, the but yeah, this is this is weird because why did adding this variant? Well, adding the variant caused the vector move to fail because the vector was containing more complicated values. It should have been getting initialized though. I mean, I'm calling the same constructor. I don't know. Anyway, now you know why I did the thing that I did, what I was intending to accomplish, um, and some context. And now I think I'm going to end the stream. I fixed my bug. I'm tempted to commit and push. None of the sanitizers are firing. I normally don't have memory errors, but I've been using raw pointers more than I ought to. That's one of the secrets to not getting memory errors in C++ is to avoid using raw pointers if you can help it. And don't call new if you can help it. Um, I don't call new anywhere, but I do use some raw pointers. But yeah. Anyway, I should be back on probably Tuesday. Tuesday at like 3 p.m. Pacific time. That's when I should be back. No, well, it's variable. Sometime between 3 p.m. and 5 p.m. Pacific time on Tuesday. That's when it will be. I've been working on this for a few weeks now. It started very small. It started as an experiment with a really nice package called CTRE that I use for tokenizing. I'll just show off the tokenizer here just because I can briefly. Uh, where is the tokenizer? Is it all in header? It can't all be in header. Well, let's look at the tokenizer test then. No, no, no. Okay. So I guess it's all in a header. Well, that's very interesting. It's been a long time since I wrote it, obviously. Otherwise, I would just know that. Uh, so here's the Lex patterns. I basically have a giant regular expression engine that goes through all of this and tells me what kind of tokens I'm looking at, like along the stream. And then I translate them into tokens here. And yeah, that's what this is all about. Um, yeah. And so it was a big experiment in using this compile time regular expression library called CTRE. It's a really well done thing. It basically compiles regular expressions into C++ code, which makes the matching very fast. Most regular expression engines compile the regular expression into sort of a pseudocode or a byte code for an internal execution engine. But not this one. This one compiles it directly to C++ code um, at compile time using templates. So it's pretty nifty. I should actually do something that illustrates just how much faster it is to do it that way. But anyway, as I said, I'll be back Tuesday. I hope that you have a good night.